Can somebody try the chat feature out and see if it works? Like, just I can see a chat over the side. Can you type into it? All right. Hello. It's good to see you guys. Schoology, as you guys have probably found out from some of your other classes, is apparently not ready for the bandwidth capability that homeschool or e-school for most of the districts across the world is providing or giving. So we'll use this until they fix that. We're going to kind of odd. We're going to start out with homework questions. So if you got them, either type them in on the chat, take a picture of the one. The bad news is I do not have a copy of that worksheet in front of me, and I can't get in the building right now. So give you guys a second, type in homework questions from that worksheet or the previous homework. If not, we will briefly talk about alternating series, then we'll go to power series. So I'll give you guys like a minute to do that. So again, send me a picture of it, type in the question, but again, I don't have a copy of the worksheet in front of me, and I don't know when I'm going to be able to get one. Hello, Kevin Barone. Hello, Tay. Hello, Kevin. Hello, Christian Wacker. Hello, awesome AL. Oh, yeah. Haha. Whoever that is. My number of watchers keeps going up and down, like 5, 7, 5, 7, 9, 2. Yeah, but it's an old username, but who is it? ALFG. ALFG. Can't figure out who that is. Oh, Adrian. Hi, Adrian. Now I get it. All right, homework questions. Wait like 30 more seconds. All right. Kevin Campbell, Beckman doesn't. Yeah, like Adrian, number 13. What is it, or can you send me a picture of it? And easiest way to send me a picture is by remind. Oh, yeah, I could. But Adrian, my brother, sent me a picture. Number 13. Oh. Let's take a look at that one. Number 13. We've got the sum from n equals 1 to infinity. And we've got n over e to the n. Okay, let me adjust everything here. There, that looks beautiful. All right. Well, first off, I see that definitely the terms are going to 0 because e to the n is going to go faster than n. I see an nth power. I see an nth power in this one, which makes me think maybe a root test would do this one in. Maybe, maybe not. Let's take a look, though. Let's take the nth root. So as n goes to infinity of the nth root of the absolute value of n over e to the n. Hold on just a second. Somebody's knocking over here. I'm really quiet. All right. Is that better? Let me see if I can. Is that better? Or let me see if there is a way I can change that within the studio. Same. Okay. Okay. Well, maybe you just need to turn me up. Okay. So I think maybe this is better. I put the microphone right by my face now. So, all right. So we got the nth root of the absolute value of n over e to the n. Okay. So let's break that into parts. So the limit as n goes to infinity. It goes to infinity. The nth root of n, the nth root of e to the n, which gets us that limit. Then goes to infinity of the nth root of n over e. And then let's talk about the nth root of n. So think of 1 million to the 1 millionth power. Yeah, and it's not fantastic, but it's better than Schoology's site right now. That's all I'll say about that one. Schoology is not having a good day today, but I think we all could anticipate that. What's up, honey? You want to say hi to my class?
Hi.
Hi. What's up?
Dad.
Yes.
Okay. I did 25 minutes of freckle.
Okay.
Now can I use my iPad?
Yes, you can. Good job, honey. Okay, let's talk the nth root of n to the n. So let's talk about 1 million to the 1 millionth power. So what number would you have to multiply by itself 1 million times to get 1 million? Well, that number has to get really, really, really close to what? Really, really, really close to 1. So the limit of n, the nth root of n, as n goes to infinity is equal to 1. So we've got 1 over e, which is less than 1. And so therefore, the root test, the sum from n equals 1 to infinity of n over e to the n converges. Is she going to growl at us? Possibly. My dog also, my dog is absolutely going nuts by being pent up in the house. He is not an in-house dog, so he may go crazy today. Okay, wait for questions on that real quick. I'm trying to monitor the chat too. Anybody else? I missed the last half of the thing because of buffering. The numerator. Okay, so what I did over here is I took the fraction that we had and broke it up into its two parts. The easy part is the nth root of e to the n is just e. That part's easy. And then the nth root of n, well, that one we had to talk a little about. Think about it like a billion. What number would you have to multiply by itself? A billion times to get a billion. Well, it'd have to be really, really, really close to 1 because just the exponent's going to kick its butt if it's anything bigger. I think of 2 to the billionth power, how big that is. So that limit is going to go to 1. In other words, it's never going to get to 1, but it's going to get as close as we want it to. And then that limit's 1. Okay, somebody asked about the absolute value. Well, absolute value, is this term always going to be positive as n goes to infinity? Yeah. Is that term always going to be positive as n goes to infinity? Yeah, I didn't say that, but that's the absolute value doesn't matter on that one because both terms will always remain positive. Let me get the light on too. I'm noticing some shadows here. That should turn the light on in this room. Here, that should eliminate some shadows. Other questions? Again, feel free to remind or to type in the chat. Right, Adrian. So 1.0, it would have to be really, really close to 1. 1.00000 to the 10 millionth power is about 10 million. And you can find that from your calculator too. And we know that because if it was less than 1, it would get really, really, really small. If it was much bigger than 1, like 1.5 to the 10 millionth power is a gigantic number. So it has to get really, really, really close to 1. Any other questions? Any other questions? That growling is my dog, by the way. That's not Emily. Yeah, his name's Milo. He's a vicious killer. Milo, cut it out. Killer. Go get her from the front door. There, we'll shut him out for a minute. No, that's not Emily. That's Milo. Sorry. All right. Is he a little terrier? I think, yeah, he's let's see what. Sorry about that, Kevin. That was held for review though by YouTube. He is a terrier like Chihuahua mix, and yes, he's got the worst case of small dog syndrome ever. All right, hearing none, let's cover a few things. Let's tidy up a few things before we go on to a power series and what that is. So power series is really going to take us through the rest of the chapter. So let's talk about alternating series and clear that up real quick. An alternating series. Yeah, you can't see that. Oh, no. Number 8. Let's go to number 8. And hopefully that matched the answer key as well for number 13. Adrian, thank you again for the text. Away we go. Number 8 is, sine squared of n. Yeah, that's a tough one. Sum of n equals 3 to infinity of the sine squared of n divided by n to the 3/2 power. Okay, so let's first talk about this. Sine and 1. So question to you, is that ever going to make this big? As it goes between -1 and 1, that's never going to make this bigger. So could we bound this one? Could we bound it in between there? Could we bound it in between 0 and n to the 3/2 power? And I see a couple of you buffering, so I'll wait for a sec. Somebody said, wouldn't it have to be between? Okay, well, why is it 0? Let's go for this then. That's a perfect question. Let's go for this. Okay, good. Now you've got it. Well, here's the reason why. If we take the sine of n and squared, isn't it always going to be positive? Yeah, it's always going to be positive. If we take the sine of n and squared, it's always going to be positive. So remember, sine squared n is equal to sine of n quantity squared. So it is always positive. So I can make that bound. However, if you're not comfortable, this bound works as well. Because this series is convergent by what test? Yeah, that's convergent by the p-series test. This series, if you take its absolute value, it's also convergent by the p-series test. And remember, if its absolute value is convergent, then it's either conditionally convergent or conditionally convergent or absolutely convergent. But either way, it's in between two convergent series. So therefore, the sine squared of n over n to the 3/2 from n equals 3 to infinity converges. Yeah, whoever said it's super positive. Yeah, it's super positive. Hey, give you a second to ask questions on that. All right, real quick. Any others? Any others? I'm gonna go calm my dog down for a second. Now my dog is barking as he hears your dog barking. Why don't pineapples wear bathrobes? I don't know. They're so prickly. Oh, what's the test for number 8 called? Sandwich is what I keep calling it. However, the official name is. There's an official name. It's called the comparison. It's called the comparison test for convergence. Because you're comparing it to two other convergence series. Obviously, summing up 0 is convergent to 0. That one's convergent by the P series. So again, this is where we take something in it that's like sneaky. Somebody mentioned that word earlier. The sneaky part is we kind of take that out and show that it has to be convergent in between there. So sandwich theorem is what we called it earlier in the year. We were trying to do limits. The comparison test for convergence is what we do to show a convergence, and then the corollary to that is the convergence or the comparison test for divergence if we're comparing it to two divergent series. How do I change my name on this? I have no idea. Oh yeah, I think you have to go back into you might even have to go back into your Google account. Okay, since I feel like we're kind of caught up for a sec there, let's, as I'm starting to do that, I was starting to talk about alternating, and let's go back to that, the alternating series. So let's go to that. And so let's just take a really easy alternating. Let's go to the sum from, nope, let's go k equals 1 to infinity with negative 1 to the k over k squared. We know converse. We know, sorry, I'm getting text messages from you guys as you're going through. We know it converges because number one, the terms are non-increasing. And number two, the limit of the terms is going to 0. So it's met both conditions of the alternating series test. Okay, so it's met both those terms. Yeah, I know. Welcome to my life. Wait till my kids start asking for lunch. Okay, it's met both conditions, so we know it's absolutely convergent. Okay, sorry. So we know it's convergent. We know it's absolutely convergent because if we remove the value, 1 over k squared converges by the p-series test. Okay, so let's talk about the sum. So I'm going to give you something to do real quick. The sum. I want you to find the sum of the first, let's go for 5 terms. And then I also want you to find the 6th term. What's the value of the 6th term? So on your own, find the sum of the first 5 terms, then find what is the value of the 6th term, and then type it in the chat. What do you want for a snack? Yes.
Dad,
I was going to print the paragraph of how my e-learning should be successful, but I don't know what printer to put in.
The Dell printer, D-E-L-L.
I could use some help looking at
Okay,
it.
I'm teaching my class right now.
Save as DFF or something.
Probably, but I'll come help you. Just leave it on the computer.
Okay.
And then since you did that you can have a few minutes on your iPad.
Actually, I want to finish it.
Okay,
But
finish it up.
I had a bit of trouble finding the practice assignment.
Okay, I can't help you right now because I'm teaching these kids, but as soon as I'm done, then I'm done for the day, actually. Yeah.
And one more thing.
Yep.
If you're done, the cat will need food and water.
We'll give it some. Be a good cat owner.
Sometimes I feel like the only one who feeds him sometimes.
Well,
Me and Mom are basically the only ones who
Mhm.
feed him.
okay, yep, sixth term. Let's go for the sixth term first. Well, give me some of you are still going here. Okay, so some of the first 5 terms, I got when I combined when I combined made common denominators. Okay, then for the sixth term, I got 1 over 36. That's pretty easy to find. Okay, so here's my question to you then. This is the sum of the first 5 terms. So we're going to call this S of 5, the sum of the first 5 terms. Sum of the first 5 terms. Is it okay that it's negative? Yeah, that just means the negative ones have a higher value than the positive ones, and that's okay. We can notice it's close to 1, but it's not there yet. How far off is this? You know, and I'm going slow and make sure I'm not. I know it's really frustrating in the live stream to try to catch up afterwards, so I'm giving you a second. By the way, hi Hannah, Amanda. I hadn't seen you guys on the live stream. Hey, Gaden. Okay, so now let's get a new definition here. For, and no, there we go. Okay, this is called the error estimate for a convergent error estimate for a convergent alternating series So let sum for k equals 1 to infinity of -1 to the k times a of k be an alternating series Hi, Andrew, too. Hi, Braden. Sorry, I hadn't seen you guys either. Let that be an alternating series that satisfies the two conditions of the alternating series test. The two conditions of the alternating series test. Then let E of n, made that a sum, E of n be the error in let E of n be the error in the sum of the series from the first n terms. Jake Canson, hi. You must still be on the Calc PC remind. Then, so our sum for the first n terms, S of n, was equal to negative 3019 over 3600. How far off is that from the true sum of the whole series? The error in that estimate is less than or equal to the next term. The absolute value of how far off that is less than or equal to the next term. So the sum of the entire series is equal to this minus this, or this plus this in between those two. So for that one we just looked at, for the previous one was a positive 136 or negative 136. It is positive 136. So the true sum from k equals 1 to infinity of, what was my series I made for you guys? Negative 1 to the k over k squared is between this minus this and this plus this. So in other words, the amount that the sum of the first 5 terms the sum of the actual series, this is the sum of the first 5. The most it could be off is this. And you'll notice as we increase the number of terms, that number is going to get smaller and smaller. This number is going to get more and more accurate. So the true sum is between this minus the error and this plus the error. The true sum of the whole thing is in between those two. And I'm moving the wrong way. And yes, I do think, yes, that's true that chat is blocked from the school accounts. Is that only for an alternating series? Yes, it is. That only works for alternating. And this is referred to by AP, assuming we still have an AP test, as the error bound. All right, give me just seconds. Logan's going to be mad if they cancel the test. I have no idea what they're going to do. And yes, I was going through making this lesson today, and I was aware that I forgot to cover that with you guys. So there it is. Good news. We all got lots of free time now. So away we go. No, that was a oops. I almost wrote a plus right there, Caden, and that was me scratching it off. It should be a minus. All right, Questionos. Otherwise, I'm going to let you guys work one. Why would you say the odds of us going back spring break are, I'd say pretty low. April 24th is when Washington State schools are going back, and I'd anticipate we'd go back around then. But here's the bottom line. We're going to do the best we can while we're here. And frankly, I'm loving the time with my kids right now. So I'm a teacher, and I'm pretty lucky. I get to spend a lot of time with my kids during the summer, but it allows me to be my kids' teacher for a little while, and that's pretty cool. So we can stay out as long as we want, as far as I care. And other thing, as I've told you guys before, like the healthcare, what does that mean for SAT stuff? I have no idea. What are the odds Chassa resume sports? I don't know. I would not say very high. A lot of this depends on how serious people take this first thing. Just to give you a story, but from my wife's work, there is a whole bunch of doctors and nurses and pharmacists that went skiing this weekend, and now they're all under quarantine because they went up into the mountains, and now they're deciding if they are going to let them work or not. And a lot of this just has to do with the real reason we're doing this is to not overwhelm the healthcare system. So, it depends on how serious people take this. I got a former student. His name's Josh Bauer. He lives in Beijing, and he was a student of mine in Minnesota. And he just wrote a post today about how like there's nothing going on. Like people go to the grocery store, people go home. They're only allowing 50 people in the grocery store at a given time, and like there are less than 100 cases, he said, in Beijing because they really clamped down, and that's what's like caused their tide to turn in that particular part. So hopefully we as Americans do that same thing. I don't know about you guys, but I went and bought a lot of food last week. So for the record, yeah, that Domino's is really clean. And, a lot of this just has to do with staying away from each other for a while. Will we graduate? I'm sure you will graduate. Will you have a graduation ceremony? Nobody knows that at this point. That's pretty far out. I mean, that's a couple months, and hopefully by then, if we take this serious, we can get back to some sense of normalcy. Also, typically, and part of it is, guys, you got to realize that hospitals are dealing with this and cold and flu season all at the same time. When the flu typically dies down, like then hospitals are not quite as busy, and that helps with managing this new virus that's out. So hopefully we're towards the end of flu season this year, and that'll help us that'll help hospitals maintain the load. And that's the real issue we're having right now, is just healthcare resources. Yeah, I did see that, Hannah, that Great with Lodge is still paying you, which is super nice of them to do. Like, that's really, really, really nice. And hopefully the school keeps paying us too. All right, I'm going to give you guys a question too. So here's what AP typically does with this. They take one and they say something. So I'm going to have you do number 3 in the AP. What's the fewest number of terms of this particular series that must be added to approximate the sum so that the error is less than or equal to 0.001? What is the fewest number of terms that the series converges to that? What's up?
Dad, would you ask your students if they would like to order?
Oh, Emily, go ahead. Emily, you could talk into the microphone.
Hello, my daddy's students. Would you like to order something from me from my cafe?
Okay, it'll take them a minute, but then they'll post comments right over there.
If you say yes, then type in, and I and my dad will text you the menus.
Ben.
I have an assignment by Mrs. Hart, and it can only be online.
Mhm.
There's no print button.
Ben, I'll take care of it as soon as I'm done teaching. Ben, it's not like Mrs. Hart's going to collect it right away. Get lots of free time. Emily's menu is junk food. Rice Krispie treats. She found Trolls Oreos at King Supers that have Pop Rocks in them. I got to tell you, the first time I had one, I didn't realize they had Pop Rocks in them, and I thought I was going nuts. What are Pop Rocks? Oh, Logan, you have to take your parents to the store and have them experience. I can't tell you what it is. 7 Up. Okay, Kevin, you shouldn't be doing this by guess and check. How many terms must be added up to approximate the sum so that the error is less than or equal to 0.001? Let me ask you a question first. What's 0.001 as a fraction? 1 over, give you a second. .001 as a fraction is what? Yeah, 1 over 1,000. Good job, guys. Okay, so you have to figure out how many terms do you have to go out so this is 1 over 1,000. Well, no, the plus or minus doesn't matter. Let me take you back. I'll take you back to the paper here. So we had -1 to the k over k cubed. So we know that we need it to be less than or equal to that. So we need 1 over 1,000 to be less than or equal to and that again comes from we need the error bound to be less than or equal to. Now, because it's equal to the absolute value, does that matter? No, it doesn't. Now, we can solve that by cross multiplying. So we get k cubed less than or equal to 1,000. Take the cubic root of both sides. Okay, so at the 10th term puts our error bound at less than that. So the question doesn't ask that, though. The question asks how many terms must be added to approximate the sum so that the error is less than or equal to 1,000. Remember, the error is less than or equal to the next term. So how many terms do you have to add together? How many terms do you have to add together? Remember, the sum of the first n terms the error in that is less than or equal to the next term. So if the 10th term gives you an error of 1,000th, how many terms do you have to add together? And yeah, the correct answer is 9. You'll notice 10 is an option though, because you get 10 is the answer to the question, but 9 is the correct answer. 9 is how many you have to add together. So the sum of the first 9 terms has an error that is less than or equal to the 10th term. The error in the first 9 terms is less than or equal to 1 over 1,000. And that's what AP almost always does with that particular set of information. All right, stop real quick and take some questions either by the Remind or the chat. I know what Discord is, Logan. Typing is hard. Check in. We could have a call so that all of us can talk. Yes, we would do that. Schoology. Schoology supports that. However, Schoology servers are getting like beat down today. Okay. Do you guys want to do another one or go to the what's next? Power series. All right. Before we go to power, I'm good with this. All right. Power series. There's a section in your book called 8.7. And 8.7 is just really wrapping this all up. Wrapping up series. Nope, going the wrong way. It's a bad part about being it inverted for me. What's up, Mr. Latanzi? You guys have been asking, like, what's my list of tests or how do I go through this? And now we've wrapped it all up. I can tell you what I go through. My number one, if I get a series and I'm asked to tell if it converges or diverges, the first thing I always do is look for the 2 easiest ones. Is it geometric or is it a p-series? If it's a p-series, we have really easy tests to be able to find that. The second one, okay, so it's not geometric, it's not a p-series. Then I go to the nth term test. The nth term test for divergence. In other words, are the terms going to 0? Now, if you read 8.7 in your book, their next is the integral test, which is not my next test. After that, I go to the ratio or the root test. The root test if it's got something to a power, the ratio test if it doesn't. Okay, still not. Okay, I go to comparison. I go to comparison test either for convergence or divergence, like we did on that sine squared one earlier today. If not, hopefully it's an alternating series. My last test is an integral test. If nothing else works, I go to the integral test or the limit comparison test. That's my list. That's what I go through. Okay. That's my list that I go through. The good news is if you've been doing the homework, this you get experience with what to look for. Like the ones you guys asked were the ones I would expect because they got a little trick into them. You got to think of it. So the limit part of the last one is the top bound of the integral. Correct. Yes. Yeah. So like integral test. We would look at the integral from 3 to infinity of something with an x that's nasty dx. Limit comparison is where you compare the terms, Kevin. The limit comparison, you look at b of n over a of n, which I'll go back to real quick and remind you guys. The limit comparison test of the terms is finite. Can you guys see that? No. If the limit of the terms is finite, then it tells you if it converges or diverges. Frankly, the limit comparison test is just the very last thing I do because you got to find a term to compare it to that. So if you think it converges, they both got to converge. And then if the limit as n goes to infinity is finite, then they either both converge or they both diverge. Other questions real quick. And you'll notice I'm giving you lots of pauses. Okay, let's go to power series. I don't want you guys to not learn anything new today and go complain to the office that you didn't get your money's worth today out of online learning, because I'm sure your other classes are rigorously moving forward. So this is really the last thing we talk about. It just takes us 3 It just takes us 3 sections to get through it all. So this is section 8.8 in your book. It's a power series. Oops, put that twice. Power series. A power series is the sum of an infinite number of monomials. An example of one what I would like you to do is write out the first 4 terms of that bad boy real quick. The first 4 terms of that bad boy real quick. Sorry about that. And notice I'm now starting to work it. Again, I'm going to be slow on this so you guys have time to work stuff. I know it's really frustrating. You get like behind the stream. No, that was squared. Squared is correct. That was squared. Oh my. And I think I said the first 4 terms, so let's go out one more. So that'll be 1 times x cubed over 4 factorial, which I think is 24. Okay. I'll give you a second to confirm, see if there's any questions or I did anything dumb. Good. Thanks, Tate. Do you have a real life example when factorial is used? Yeah, exponential growth. Can anybody think of exponential growth that's going on in the world right now? But yeah, most of it's probability, like the number of ways to count something. And I will back up. Let me look ahead for just a second. I think the sine and cosine. Yeah. Shockingly, wouldn't it be more logistics fuzzy? Shockingly, sine and cosine are going to have something to do with factorial soon. Yeah, shockingly, they're going to have something to do with sine and cosine. I don't want to get too far. There's going to be a Taylor and Maclaurin series that has to do with that. Okay, so now here's the key question we're going to ask ourselves. The key question: what values of x does this power series converge for? Or does it never converge? Or does it never converge? Or does it always converge? Like, it doesn't matter what the value of x is, it always converges. And here's the large part for this of why I like the ratio test is because we use it for the power series, and we might as well get used to it. For the vast majority of them, we're going to use the ratio test to be able to determine what values of x it converges, what values of x it diverges for. Wait for just a second for any questions you guys have. All right, let's hearing none, I'll go on to a very good, rigorous definition. The definition of a power series. Sum from k equals 0 to infinity of a to the k times x to the k, where a to the k are the constants for each term. Another form of this an algebraic difference is the way to show that a alternating series is non-increasing. But frankly, we just take the derivative most of the time to show the derivative is always negative. Remember, there are 3 ways to show that, this is Adrian's question, 3 ways to show that an alternating series is non-increasing. One is to show the derivative is always negative. One is the algebraic test, and one is the, I forget what is it called? The algebraic ratio test. We have early lunch today. Let me go through this, and then you guys can have the rest of the day off. This is another form of the power series where C is the center of the power series. And a duck question in this form up here, what's the center of our series? Right, the center's at 0. And I think that's a good place for us to leave off, actually, for today. Link at Keynes. Today's a special schedule. So the algebraic ratio test, and yes, the algebraic ratio test is a way to prove inside I'm going to change my mind. I'm going to do one example. I'm going to change my mind. I'm going to do one example. Because that'll set me at a better place. Sorry. I know hot dates y'all got for lunch. Haha, your phone dinged. You're hilarious. Yeah. Yeah. So let's take a look at an example. Let's do a really easy example of power series. So example number 1. Let's look at the start at 0. That's what I was supposed to miss. I kept stalling. Note. Notice they started k equals 0. So the very first term of these, the very first term is going to be a constant. The very, very first term is a constant. So let's go for an example. Sum from k equals 0 to infinity of, let's go k to the x over. And our question is, what values of x does this series converge for, if any? No, they for a power series, they always need to start at 0. As weird as that is. For a power series, they are always going to start at 0. It's going to be where I talked earlier in the semester and you guys were like playing me like reindexing wasn't a big deal. Reindexing becomes a big deal. Okay, so how do we determine where it is? Okay, we go to our ratio. As n goes to infinity of a of n plus 1 over a of n. Did I put those backwards? No, I have those correct. I have those correct. Is less than 1. If that ratio is less than 1, then the series converges. Okay, so let's see when it's less than or equal to 1. So let's substitute in the limit as n goes to infinity of x to the n plus 1 over n plus 1 factorial. And then we remember that when we divide by a fraction, we just multiply by the reciprocal. So we get n factorial over x to the n. And it converges when this is less than 1, if it ever is. Sometimes it will be less than 1. Sometimes it won't be less than 1. All right, so then we know n and n minus 1. Well, first off, can we drop the absolute value? No, we can't, because x could be negative. We have to consider the values of x that could be negative. So we get the limit as n goes to infinity of, okay, x n plus 1 factorial, n plus 1 is n plus 1. X to the n plus 1, x to the n is just x to the n plus 1. Actually, I lied to you. No. Let's say if n is equal to 5, we've got 5 x's here, we've got 4 x's there. What do we have left over? Right, we just have 1. We have x to the 1. Because if n is equal to 5, we'd have 6 here, we'd have 5 there, we've got 1 more. We've always got 1 more x on the bottom than the top. It's not a factorial. That was dumb. That was dumb, Beckman. So we've got x to the first divided by n plus 1 factorial. Now this term no longer has any n's in it. Take it out. So you take the absolute value of x, multiply by the limit as n goes to infinity of 1 over n plus 1. Question, what is that limit going to as n goes to infinity? What is that limit going to as n goes to infinity? It's going to 0. So we've got the absolute value of x multiplied by 0 is less than 1. When is the absolute value of x multiplied by 0 less than 1? It always is. So this series from k equals 0 to infinity of x to the k over k factorial converges for all values of x. It's always converging. Converges for all values of x. All right. Now let's have you guys try one. Stop and check up though. Any questions? I haven't seen any questions for a minute, so hate for you guys to be late to your lunch date. So would X have to range because it's an inequality? Yes, it will. In fact, the next example I want to do is going to give you one that gives you a range. Today's a special schedule. We get out at 12:30. Does absolute conditional convey? Good question, Amanda. Amanda, did we? If this converges, would its absolute value converge? Good question, Amanda Warren. You get the special snack from Emily first. Did we need absolute value for? Let me ask you a question. Do we need to put this in absolute values for it to converge? Does that change any outcome on that? No. Good question, Amanda. So it absolutely converges, which I just slaughtered the spelling of, but just a second. My wife wants to talk to me for a sec. Yes, here. Well, no. Where do you go? All right. Okay, great, good, absolutely. Law and Order SVU. All right, let's have you guys try one. Let's do example 2. Let's go the sum from k equals 0 of let's go k times x to the k over let's go for 5 to the k. And I want you guys, no comment. What was I supposed to comment on? Oh, we need to learn. Absolutely great. All right. Let's have you guys try a ratio test on that. For what values of x does this converge? For what values of x does this converge? Ready, set. Let's walk there, really, guys. Sounds like a dream. All right, so let's take our ratio test. So the limit as n goes to infinity of n plus 1 over x to the n plus 1 over 5 to the n plus 1 multiplied by 5 to the n multiplied by x to the n. We want that absolute value to be less than 1. All right, so now let's go for, okay, we got x to the n plus 1. That leaves an x up here. N plus 1 over n, that's not going anywhere. 5 to the n plus 1, 5 to the n, that leaves us with a 5 downstairs. So now we got the limit as n goes to infinity. The absolute value of n plus 1 over n. What else we got left over? We got a 5 in the denominator, so we've got 5n, and we've got an x in the numerator. For it to converge, that has to be less than 1. All right, so now this has nothing to do with n, so let's take it out. Now, as n goes to infinity, what are these? N plus 1 and n are going to get really, really close to what? Really close to 1/5, right? So you have the absolute value of x multiplied by 1/5 has to be less than 1. So the absolute value of x has to be less than 5. So the sum from k equals 0 to infinity of k times x to the k over 5 to the k over 5 to the k converges when absolute value of x is less than 5. Okay, that's where we're going to stop for today. We're going to leave it there. Now, I have to have a question. What about, oh, sorry, that's a good question. Whoever said that. So it's between -5 and 5. What about when x equals 5 and x equals -5? What about those 2 points? We will pick that up next time because I am getting close to an hour and a half and I don't want to go into your other classes. So what about those two? Would the root test work? The root test works for this one. I feel like this worked out pretty well, though. But same thing, you have to get the absolute value of what's inside the root to be less than 1, and that would work as well. To be honest with you, I just used the ratio test for darn near all of these. So what about these two? So in other words, we're going to have to test the endpoints when we start tomorrow. Test the endpoints. All right, let's take a look at some problems. I got to get a couple alternating series in here. Alternating series. So for this, let's start on page 6. Where are these problems? It was 689. I want you to do 2 and 5. And then I want you to go to page Let's go for page 709. And let's, I don't know, 13 through 16. Can we do any others? 13 through 16. No, that's it. That enough? No, we got to keep you guys busy. We don't want kids doing drugs on these days. So then let's also go to page 699. And let's go for let's go 7 through 10. And hope everybody's feeling good. Hope everybody's staying inside, staying away from people. Any questions before we go on? Questions before we go on? Walk into Castle Rock this summer. Cactus. What does that mean, Jack? Any others? Good thing I have some math to do. Otherwise, I'd be addicted to drugs. Good. The only drug I'm going to do is antibiotics for corona. Wait a minute. I just hate to break this to you, Adrian. It's coronavirus. It's not a bacteria. Antibiotics won't do any good for it. Will you put that on a reminder? Yeah, Taylor, let me do that right now. And then I better also tell you. All right. Maybe if I'm on drugs while doing my math homework tonight, I might understand it better. Oh, all right. Have a good night, guys. Have a good one. See you on Wednesday, guys. Bye.